Dear students, welcome to problem solving session number 2 in the level 3 of our problem solving session in the chapter of gaseous state. So this is our second problem solving session, and the first problem of this session is this, that we have a 100 dm³ flask or a 100 liter flask which contains 10 mole each of nitrogen and hydrogen at 700 Kelvin. Now after equilibrium was reached, the partial pressure of hydrogen was 1 atmosphere. Now at this point 5 liter of water in liquid state was injected and the gas mixture was cooled to 298 Kelvin. Now we have to find out the gas pressure. Now reaction of nitrogen and hydrogen usually forms ammonia. So this is the equation for the Haber's process that we have to solve. So I can say that the equation is N2 gas plus 3H2 in gaseous state again, and what you are getting 2 moles of ammonia. So if we move along with the problem, we can say that N2 plus 3H2 is giving me 2 moles of ammonia. So initially there are 10 moles of nitrogen, 10 moles of hydrogen and 0 moles of ammonia. This is the situation at the start of the reaction. Now at equilibrium, suppose you have 10 minus x moles of nitrogen, 10 minus x moles of hydrogen, and here I have 2x moles of ammonia. So at equilibrium we can say the moles of hydrogen is equal to pressure of hydrogen into volume divided by R into T. So this is a direct help from the ideal gas equation. Thereby we can say that this is equal to pressure of hydrogen, which is equal to 1 atmosphere, multiplied by their volume, which is 100 liter, divided by 0.0821 multiplied by 700. So this gives you a value of which is equal to 1 divided by 0.5747, which is equal to 1.74. So this is the number of moles of hydrogen. Now as per the equation we can say that 10 minus x or 10 minus 3x is equal to 1.74. This will be 10 minus 3x, I'm sorry. So 10 minus 3x is equal to 1.74. Therefore we can say that 10 minus 1.74 is equal to 3x, or we have the value of x to be equal to 2.75. Therefore the number of moles of nitrogen or N nitrogen is equal to 10 minus x, which is equal to 10 minus 2.75, which is equal to 7.25. Number of moles of hydrogen I have already calculated. This is equal to 1.74. And what is the number of moles of ammonia? The number of moles of ammonia is equal to 2 into x, which is equal to 2 multiplied by 2.75, which is equal to 5.5. So after water is injected, we can say the gas mixture is cooled to 298 Kelvin. Now this ammonia which is present there will go into aqueous state because due to the formation of ammonium hydroxide by the following equation. So you have NH3 which is gaseous, plus you have water in liquid state, and you get NH4OH. Now, so the volume of flask available will be equal to 100 minus 5 liter, since 5 liter of water was introduced, so which is equal to 95 liter. So if 95 liter is the volume of the flask available, therefore I can say that the total pressure can be calculated by the ideal gas equation. PV is equal to nRT, or I can say that P total is equal to nRT divided by V. So what is the value of N total? The value of N total is number of moles of nitrogen plus the number of moles of hydrogen. Into R into T, which is 298 Kelvin. Now we shall be putting the values, divided by V volume, which is 95 liter. So now if we substitute the values in this particular equation, what shall we get? So P total becomes equal to 1.74 plus 7.25 multiplied by 0.0821 multiplied by 298, this whole divided by the volume, which is 95. So this gives you a value equal to 219.947 divided by 95. Unit of pressure will be here atmosphere. So this is equal to 2.31 atmosphere. So this was a very good problem based on the ideal gas equation, and also a little knowledge about the chemical equilibrium. So I believe you have understood this problem, which was a very important problem for your competitive examinations.